Yeah, thanks again for having me, and I also have a little bit more time since as on the first day, so the first day was maybe quite quick over some features, and today I have the time to go a little bit more detail on the stuff we have created based on Semantic MediaWiki. Yeah, so just as a very brief background, so my institute is about material science, so we do this fancy stuff like nanoparticles and batteries and biomaterials, and we have of course labs where we collect data, and data collection is always a mess, so we of course work with all these Excel sheets and nodes and distributed file systems, and that's why we have this this institute strategy of course digital transformation. And we see this as a multi-stack approach. So we need to start at the physical layer. Of course, we aim to automate also testing and material handling to collect the data already automatically. But of course, humans are still important because they're the most flexible machines out there. So we need to include humans always in our workflows. And we need to provide this hybrid information layer on top where every actually feels well and can read and write information. This is of course especially true for AI and machine learning agents that also are operating in the space. And of course we all share this long-term vision of having these fair data spaces where we can really exchange semantically annotated data with other parties without explaining anything on top. We also, we have, our system is, as I said, the general idea is that we have an OpenSemanticLab stack that is very generic, so you can put different data schemas inside, and then you can get different applications from that. So we do not want to have one ALN system to taking notes and one project management solution and one ontology explorers, or we want to have all in one system, or at least on the same software stack. And the idea is that we have the knowledge graph always in the center, and then you can allocate different resources in this knowledge graph, like the inventory you have, the processes you want to follow, and the data interfaces you may want to incorporate and feed into dedicated data stores. The computational science tools you may want to apply on your data, and of course AI tools that can operate on this knowledge graph, as we also heard in the last talk pretty much about. And we also so this is our development, and we are also quite proud that Fraunhofer has also a web application farm just for interest. This is for 70 institutes with 30,000 people and researchers. We have a central application provider where you can, in a few clicks, get one of these applications. And you see there is MediaWiki, there is Wikibase, and MediaWiki, they mean Semantic MediaWiki actually. And we are also proud to have OpenSemanticLab now also as a flavored Semantic MediaWiki for all our Fraunhofer colleagues. We have, of course, two perspectives, and the first perspective is human-centered tools. And this is what we love about Semantic MediaWiki, that it has a very strong point there. And we all know the visual editing. This is what we get for free. We have this knowledge graph visualizations, which is a nice addition. And I will also show some other editors for spreadsheets for, we all know Draw.io. Also some chemical stuff. We also use, of course, specific visualization handlers for files, and of course we make first implementations of chatbots in the system. And the other perspective, also introduced on the first conference day, is this data perspective, this machine perspective, and here's our stack in the middle. We migrated everything to JSON as a data store, and as already explained, we use JSON schema as a modeling language because we then can auto-generate all user interfaces to manipulate data. We can also feed in the data programmatically, and we can use JSON LD. So we do not write any set parser function for Semantic MediaWiki. We just provide a JSON LD context because this is well understood in the whole industry, and we interpret the context then with Semantic MediaWiki API, of course. But it's not something anyone has to do manually. And we hear a lot about LLMs, and the great thing is that LLMs start very unstructured, and now they become pretty capable to provide structured context. So they fit well into this JSON schema approach, because we can then enforce JSON schema structured output. And we hear already a lot about that you can write agents that can operate on an RDF graph and make use of this his preciseness to validate information or get precise information. And we also believe this is important, that our combination of schema and semantics with this industry de facto standards can provide, so we call it OOLD, can really provide automated transformation between syntactically different notations of the same semantic context. So a very popular example, in science, some people put the samples to the measurements. Those are the people who do primary measurements, and other people put it vice versa, so they put the measurements to the samples because they are primarily focusing on their own sample. And it semantically totally makes no difference, but syntactically it makes a difference, and this is a chance to have both perspectives without having two separated systems. And also a very public example, we know the European Commission wants to have a battery passport to have all the data about an electronic vehicle. And there are multiple initiatives. It's not only two, but it's more initiatives. They create data schemas, and they are all different. So it's the same information by regulation, but we find 2, 3, 5 data schemas for that. And the question is, how can we translate in between? But the essence of our approach is you have a schema repository. It would be nice if we can share it, so you can find something already existing. Great, you do not have to write your own schema. And you also can aggregate schemas to, for example, you take a description of a battery and a description of a testing procedure, and then you just join them, and you have a battery testing procedure schema, and then the user gets his form to fill out manually, automated, AI support, however, but actually he creates a JSON LD file, and then this can be then submitted to any digital workflow that handles the next steps. We have a lot of projects going on where we use this platform. Most, of course, are in material science, especially in battery science, but it also helps us to get the platform better and better by iterating it into the research projects. But especially I want to provide some demo because maybe that's the most interesting stuff. So I will start with our core knowledge base in our institute is called ArcEve. So it's kind of where you put everything which is relevant for all 300 people. And there is like documentation, and you can find tutorials, you can find projects or calls you want to join as a team. You can also find the people and devices in this knowledge base. So, and the example is, and we also you can search for people. For example, I can search myself, and then we get a hit, and with this citizen skin it already looks nice, and we can also incorporate the Semantic MediaWiki API in research results, provide a preview picture. But you may notice that I'm not a user with title Simon _ Stier, but I'm an item with a UUID, so it means that we need to translate every UUID in the system to a label. So this is of course a little bit tricky, but in the meantime we kind of be successful in having UUIDs globally, so there's nothing that is clear named, but every interface the user gets has the display labels. Of course, it's then easy to change them because the UUID doesn't change. Yeah, and a good example what we really use a lot is our project management. So we have a list of all the projects we run, and it's really nice to keep track of them because you have a proper idea what is the list of active projects, who is leading in this project, what is the duration, so we can also have all these nice MediaWiki features to see, okay, what is the workload, do we face a funding gap, and we also have nice feature implemented ourselves, which is a Kanban board. It's just a little bit JavaScript that displays task entities, and you can of course create new tasks with a priority, and you can edit them by using the schema, and you can for example also drag and drop tasks. So it's just a wiki article representing this doing, and you can manipulate this in a single interface without navigating to all the pages manually. So this is what we pretty much love ourselves. Yeah. And actually, because it was also, Robert also discussed with me about what we did in regarding custom editors. So we have not only the Draw editor, you may all know, so you can provide drawings, and this is embedded into the web page, so you really can quickly make concepts. We use this really a lot. This is a great tool. So you can manipulate this, and then you can save it. So it's of course not what we develop, but just use it. And what we added on top is a SVG drawing editor. It mimics the behavior, but here you can make some drawings freestyle and can make some notes. But the basic principle is the same. So you can manipulate an SVG file inline, and you do not change the editor. And we also had this spreadsheet editor because people love Excel. So this is the same principle. So you can have a tabular sheet, which is actually stored as a JSON file, so you can really have a good machine access to it. You can also have some styling and formulas. So people really want to have the Excel. You may embed it into a web article. Then you can find it, and you can access the content also with scripts, for example, to maybe populate templates or extract the information from templates. That was the basic idea. The previous pretty primitive is just a screenshot of the Excel sheet because it was hard to render the Excel sheet without loading all the JavaScript stuff, but it kind of works that you see what is inside the Excel sheet. Okay, so this is what we did visually, and you know already from the first talk that we have this this rich collection of schemas. So we have entity, and we have item, then you have event, you have people, and you have places. So we really build this ecosystem of categories in MediaWiki language. They all have a data schema. They extend each other's data schema. So we have this rich collection, and we also publish this all on GitHub. So the idea is to exchange these schemas more and more. And all our instances use the same inventory of schemas, and we just develop them further. And so every schema can also create such a tile. So we have a category, and we use, for example, UTF icons because they are simple to use and explain clearly what you need. And again, the schema then provides this editor where you can create an instance of the schema. And what we also pretty like that you cannot only have, maybe I switch to English here. You cannot only have text fields, but of course it's important to have all the stuff we know about restrictions so the JSON schema can provide enumerations of valid entries, can validate if it's a number or not, and all the stuff. For example, this would be a drop down that is statically defined in an enum. Here we have a project status, so you can find an inventory of terms that define a project status. And if you want to incorporate, for example, people, then you have a list of, here, for example, the project lead is then a person, so you query with the Semantic API all instances of category person. And the great thing is, if you miss a person, which may occur, then you do not have to leave the editor, go to the person schema, create a person, and then go back. You can just hit create inline, meaning because the editor knows what is the target schema, you can also use the target schema and makes another editor layer on top, and you create a new person on the fly. And you can store this. You can even go further. If you now miss an organization, you can create an organization. You never need to leave your workflow. And if you save this, then I can do this maybe for demonstration. If you save the information, then this person is created on the fly in the background, and the field is then populated with the person. So we right now created a person. It's now in the system, and we make this very efficient. Okay. Future features are also including reverse properties. We can also make links to entities that are backlinks from entities that are referenced. And as said, if you create any instance in the system and you store it, so there's some validation. Okay, I maybe skip this here. If you store it, then of course we render this all with some templates and okay. Okay, maybe the internet connection is not that. Okay, I go ahead. It's not that critical. Here we, for example, see any demo page. If you save the page, then you get a rendering. You have an infobox, which is fully automated, created from the schema. The schema knows which properties can occur. You have the label of the property. You have, of course, the type, if it's a link or not. And you always have the knowledge graph that, so we have all this, for example, the people who are involved. You can then also explore the knowledge graph. So on saving, you have this all on the RDF triple store via Semantic MediaWiki, and you can explore the data directly. Another pretty nice feature we revived kind of is WebDAV support. So if you upload an Office document, then you can click on this open with Excel, for example, and then will open, if you have it, Microsoft Excel, and you can manipulate the file on the fly, so you do not have to download it and re-upload it, but you can open your Excel. You need to activate editing. You may write some new data again, or can also use, of course, Word and PowerPoint. And while clicking on this sync button, we may know from SharePoint, should then re-upload the file with your edits, and you see in the change log now we have edit through WebDAV from today. So this is a little bit mixed up, but if you reload the page, it's correctly displayed. So that's pretty neat for people mixing Microsoft Office and the wiki, obviously. Okay, but of course very important is AI also for us, and we have here one of our projects, a battery knowledge base, so having research data on batteries, and we have of course all the stuff like institutions that are researching, the researchers on the institutions, technical aspects of batteries, and of course this is a good use case for AI agents, and our implementation here is that you have the search bar as you know it. For example, asking who works at a certain, at a SINTEF, it's a Norwegian research institute, and then you can search as usually, but you will not find this information by typing this question, but you can also ask the chatbot, which submits the question directly to AI chat, and this AI chat uses the triple store to write down the triples in small sentences. So this is idea already was presented last year, and it works pretty well because it's very precise, the knowledge. So we now know that Simon Clark works with SYNTIF, which is correct, and we know that base for this assumption is that SYNTIF is an organization and Simon Clark is located in the SYNTIF battery lab. So we have this paraphrased triples from the knowledge base, and this is then used for RAG, which is feed into the LLM, and you can also jump to, this is actually a link, so you can jump to the wiki article which actually makes the statement. So this is the battery lab, and here is the main source of information. So here Simon Clark is listed as a researcher at SYNTIF. So you can really validate information, which is pretty nice. This also works with documents, of course. This is, I think, it's of course very well known. So maybe a battery researcher may ask, how can I measure a thickness of a coating, which is important for them. And in this case, the information is maybe, in this case, the information is on uploaded a PowerPoint presentation. So in this case, we also populate the RAG with not only the wiki texts, the wiki pages, but also from the documents. And here's also the correct answer. And the citation points now to wiki file page. And the wiki file page is an uploaded PowerPoint presentation. And on page 11, there is a slide that actually provides the answer. And this is, I think, pretty nice that you will never look up all these pages down in many PowerPoint presentations, but if you can just put a question, you get an answer, but you can also validate the answer by going to this location. And ideally, we can also visualize this location by the tools presented on the first day. Yeah, because the question also was put out how we can, how fast is this, so we can, I don't have time to, it's very, I think we are out of time to show this, but if you create a new article, like Vienna is the city of knowledge, maybe, and you store it, and we get the event chain of new articles, and we feed it to the RAG. So maybe a few seconds, and then you have the information available in the AI chat. So you can really, people can create new stuff, and a few seconds later, the LLM will also already answer based on this stuff. Yeah. So this is pretty neat. I can demonstrate it, but I think it's not feasible. But I want to repeat the point that we also have this AI form completion, which is very nice to create initial content. So like if you want to write an article about Semantic MediaWiki, then of course the model has maybe some knowledge about Semantic MediaWiki, so you can just look what the model maybe pulls out as a description and also translate the description, which is nice. And it's maybe kind of useful, and you can go ahead. So you can really create fast items that are based on pretty known concepts. We already had this example where we have from the first day where you uploaded a PDF which has listed authors in an abstract text, and you want to populate the graph with this information. So you upload the abstract PDF, and then you wait for the AI model to populate the knowledge base. So this would be the abstract text, and in general then the author list can be extracted from that. So maybe give it a second shot. So we are really experimenting a little bit how we can really enforce the output. It mostly works well, but sometimes not. I think it's also based on the history of chat. I think it's also important that the context is not refreshed and maybe influence the outputs. But also what we have regarding important for us as data scientists is often that we need to incorporate CSV files, and also here is the idea, for example, you upload a CSV file and then you need to extract information, what is the separator in the CSV file, what are the columns, what are the units, and you may ask for AI support to provide you a specification of the CSV file to make automated consummation happen. Yeah, so we have a lot of ideas in this direction. Yeah, and finally, this is an important point, that we also have this like a concept editor. We call it characteristics, because creating new schemas is, of course, if you really need to write JSON schema, it's a lot of work. So we came around with a meta schema to creating new schemas, and this is also useful, of course, with AI, because if you want to create a new schema, you maybe provide just a description of the schema, like please create me a characteristic for a person according to schema.org, and then the tool has, of course, a certain pattern how to define new properties. Okay, I'm really out of luck in this demo, but this editor really is like a concept editor, so you can add new properties on the fly. And after you have done this, you can use the generative schema to create new properties. Yeah. So now it works. So we have a name, a birthday, and an email, and we have a description for the stuff in multiple languages. And you can save your new created schema. And after that, you can create an instance of the newly created schema, so you have directly can create persons then now by the defined properties you have. So this idea, use AI also to speed up developing of new characteristics. Okay, yeah, finally, yeah, we hope that this is really yeah, a new way to edit data, and we also think a lot about how ontologies can be used more easily. So we also created a schema for our ontologies to provide a more simpler editor for terms according to the OWL standard. And also this is something where I can say MediaWiki is much more friendlier than Protégé, and you can also attach multimedia information. You can visualize these concepts. And I just want to point, because what was asked that we also can use, for example, Sparklist. This is a UI to explore RDF graphs with a visual tool, so you do not need to write Sparkle queries your own, but you can click queries and you can see what else information can be used to filter something, for example. Okay, yeah. So finally, yeah, we use the MediaWiki very flexible. We are very happy with the flexibility. Performance is a little bit downside currently, and we have really a lot of useful demonstrators out now, for example, also to create a very complex documentation of analytic jobs in our lab, where we also have workflows where we can then submit all the data, because it's just JSON to a REST API, and the REST API makes calculations, and finally the REST API creates a PDF report. So it's a fully auto-generated report by data that was collected in the MediaWiki, using the schemas to guide the user to the different steps. And the aim is here really to speed up a process that usually takes 6 hours per step, per report, down to maybe half an hour. Yeah, okay, there are a lot of other use cases. I skipped that. You already know our knowledge graph. We also explore solutions for lifecycle assessment, because then you also need a lot of good quality data about processes. And we also have a virtual lab solution where people can submit, for example, a new recipe, and then we have a robot that actually works in the lab and mixing materials to get a target material, and you can make this all in the web interface. Okay, thank you a lot. Sorry for taking too much time.
Maybe one or two short questions. Yes.
Some of that functionality, is it available via extensions? Like the SVG editor or the Excel?
So it is not in ideal shape, but it's all on our GitHub repositories. I can also link them in my talk description. Also, Robert asked for a list of repositories, so yeah. It would be good to have this editor in a well-maintained state. Yeah.
So yes, thank you for this presentation. It is very inspiring. I really love the tools that you have come up with, and surely we'll look into them and see if they can be reused. That's great. Just want to say thank you.
Thank you.
Thank you very much, Simon.